So on page 158, we're going to graph exponentials by hand, and the first two things that are always easiest to do is asymptote is the first easiest. It's going to be this value out here, so -2, so y equals -2. And the second easiest right here is going to be my y-intercept. So to find my y-intercept, you let x be 0. So to find my y-intercept, I plugged in 0 for x. And so you're going to get that 4 to the -3rd minus 2. 4 to the -3rd is 1 over 64 minus 2 is going to get you this fraction of -127 over 64, which is about -1.98. So there's my y equals -2 asymptote, and there's my y-intercept. And then I need to find another point on the graph. Well, if I plug in something for x right here that would make this really easy to deal with, something that I could plug in right there for x to make this whole equation easy to deal with would be -4. So I made a little table, and I'm going to plug in -4 for x. So I get 4 raised to the +4 because a -4 makes a +4 minus the 3 and then minus 2. So 4 minus 3 is 1, so 4 to the 1st is just 4. 4 minus 2 is 2, so I now know that I have a point at 4, 2. And then the last thing I need to find is probably an x-intercept. So to find the x-intercept, you're going to let y be 0. So I let y be 0. So now I have 0 equals 4 to the -x minus 3 minus 2. And then I added the 2 over. So I have 2 equals 4 raised to the -x minus 3. And then I'm going to rewrite this. I can rewrite 4 as 2 squared. And this 2 is really like 2 to the 1st. So now I have 2 to the 1st equals 2 squared raised to the -x minus 3. By rules of exponents, you're going to multiply this together. And so you're going to get that this power over here is really like 2 raised to the -2x minus 6. For this to be true, a true equation, 2 to the 1st has to equal 2 to the -2x minus 6. Since these bases are the same, these powers have to equal each other. So I now have 1 equals -2x minus 6. I'm going to add my 6 over, divide by my -2, and I find out that my x-intercept is -3.5. So there's my x-intercept, and I plotted it, and then I can draw my awesome graph. The domain in general for all exponentials is going to be -infinity to infinity, and the range in this case is -2 up, so -2 to infinity. Even though this is a growth graph, because there was a reflection, if you draw little tangent lines along this, it would actually be decreasing, and then we finish this graph. So pause the video and try the next graph, and then go back to Edmodo and see if you got it right. So here's the next problem, and the first thing I did was I said, okay, I'm going to rewrite this equation. So I rewrote it like this. So I know that this +1 right here is my asymptote. And then that was the first easiest thing. The next easiest thing to do is find the y-intercept, and to find the y-intercept, you plug in 0 for x, which is what I did right here. So I have -2 times 0.5 to the 3rd because I plugged in 0 right here, and 0 plus 3 is just 3 plus 1. And then I typed this in my calculator and got 0.75 or 3/4. So now I know what my y-intercept is, so I graphed my y-intercept and I graphed my asymptote. And then I want to find another point. So something that I could easily plug in to find another point would be something I could put up here. Well, I have enough points. I know what's going to happen this way. I need to find something on this side. So I picked -2 because if I plug in -2 right here, -2 plus 3 is just 1. And 0.5 raised to the 1st power is just 0.5 or 1/2. So I plugged in -2 and I got -2 times 0.5 or 1/2 raised to the 1st plus 1. 0.5 raised to the 1st is just 0.5. Half of -2 is -1. -1 plus 1 is 0, which means by luck we just found the x-intercept, which is -2, 0. And now I can, now I can go along my merry way and finish answering these questions. I made my graph. Domain is -infinity to infinity. My range is -infinity up to 1. I found my x-intercept, my y-intercept, and this graph is increasing. And now you're all done with this problem. This is the kind of math you need to show on pages 159 and 160 when you do your homework.